Welcome everyone, I am Harish and will now present our paper Masked Reconstruction-Based Self-Supervision for Human Activity Recognition. The availability of wearable sensors such as accelerometers and gyroscopes on commodity smartphones and smartwatches has made large-scale collection of movement data a straightforward endeavor. However, labeling the collected data still remains challenging as the annotation process is expensive both in time and monetarily while having privacy concerns as video needs to be recorded synchronously. Due to these factors, publicly available labeled datasets tend to be limited in size and in variability. As the data collection process itself is more straightforward compared to the annotation, it raises the question, can we leverage unlabeled data? Is it possible to utilize unlabeled data to improve performance on labeled datasets? In order to do this, we introduce masked reconstruction as a self-supervised pre-training objective where unlabeled data is utilized for pre-training. This brings us to our next question. What is masked reconstruction? We begin with a window or frame of data obtained after applying the sliding window process and randomly choose 10% of the time steps. All the sensory data at these time steps is masked or set to 0 and the modified input is passed through a series of transformer encoder and fully connected layers in order to reconstruct the input. Only the sensory data at the masked time steps is chosen and mean squared error loss is computed between the unmasked data and the reconstructed output. The network is forced to look at the surrounding values in order to reconstruct the missing data. This incorporates temporal context into the model training, which is beneficial towards learning on time series data. The entire process constitutes a pre-training step, after which the learned encoder weights are frozen and utilized along with an MLP classifier for activity recognition. We now take a look at the activity recognition performance of the proposed technique and compare it against both supervised learning and unsupervised learning baselines on 4 benchmark datasets and study the test set F1 score. Compared to deep kernel STM, which is the supervised learning baseline, we improve performance on 2 out of 4 benchmark datasets while performing comparably on the third. We achieve a maximum relative improvement of around 10% on one of the datasets, thereby showcasing the usability of the technique as it does not require labels for learning, whereas deep kernel STM does. Compared to the convolutional autoencoder based unsupervised baseline, we improve performance on 3 out of 4 benchmark datasets, showing strong performance even in the unsupervised learning scenario as well. Putting everything together, we introduce masked reconstruction as a self-supervised pre-training objective and demonstrate improved performances on both supervised learning and unsupervised learning baselines. The proposed technique can be utilized as is in activity recognition chains in order to improve performance. We would love to hear your thoughts, so please contact us at